So this is circle. This is the center point. This is called the chord. Theorem 1 is saying that a straight line drawn from the center of a circle to bisect the chord, which is not a diameter, is at right angles to the chord. So a straight line drawn from the center is O, drawn from the center of the triangle, bisect. Bisect means equally divided into two parts. Let's AB is the chord and this straight line from O to P. Bisect the chord into equally two parts. You have to prove that it's bisect at right angle triangle. That means these two angles are right angle. So let's join this OB and OA. OB and OA. From here, now there are two triangles formed here. After joining AO and OB, you are getting two triangles, and in two triangles, triangle AOP and triangle BOP. So triangle AOP and BOP. Now we have to prove these two triangles are symmetrical. AO is equal to, from this triangle if you will observe, this is the radius touching the circumference to the center. So this is radius. This is all the radius. So AO equal to OB. So AO equal to BP and OP is common to both the triangles, and it is given that AP equal to BP. So these two triangles are symmetrical. So this implies triangle AOP and triangle BOP are symmetrical. On what basis? On S. That means side. That is, all three sides of one triangle is equal to all three sides of the other triangles. Now, if you see, what you have to prove? You have to prove that these two triangles are right angles. Okay, got the point? So these two angles are right angles. Suppose now here you see since these two triangles are symmetrical, so angle OAP equal to angle OBP. Similarly, also angle OPA is equal to angle OPB. Isn't it? OPA and OPB. So these two triangles are equal, but OPA, angle OPA plus angle OPB is equal to 180 degree, because AB is a straight line. So any point P, if you omit this is 180 degree at point P. So 180 degree, since AOP and plus OPA and OPB is equal to 180 degree. So angle OPA equal to OPB equal to 180 by 2 equal to 90 degree. So now you got, so a line drawn from the center of the circle to the chord AB, bisecting the line A chord AB in equally two parts. Then the straight line touches the chord AB at right angle. So that is the theorem 1. What is the theorem 1? Suppose a straight line drawn from the center of the circle to bisect a chord into two equal parts, then that straight line also touches the chord at right angle triangle. This is theorem 1. So you are like this, you have to prove it. So this is the proof and this is the theorem. This is all about theorem 1. So we will now come to theorem 2. Now we will come to theorem 2. So what is theorem? Theorem 2. Theorem 2 is nothing but opposite to theorem 1. In theorem 1, what is it told? What is told? Straight line drawn from the center of the curve to the center of the circle to the chord, bisecting the chord at equal parts is at right angle. Bisecting at right angle triangle. So now, if a straight line drawn from the center of the circle to a chord at right angle, then it bisects the chord equally. That is theorem 2. So let's prove it. A, B is the chord, O is the center of the circle, and if a straight line drawn from the center of the chord, center of the circle to the chord AB at right angle triangle, then you have to prove that these two are equal. That is AP equal to BP. You have to prove. Given, what is it is given? Given angle OPB equal to degree, angle OPA equal to 90 degree. So how to prove that these two are equal? To prove AP is equal to VP. This is you have to prove. How you will prove it? Now let's join it. AO and OB. So by joining this AO and OB, we are getting two triangles, and triangle AOP and triangle BOP. So these two triangles. Now we have to prove that these two triangles, these two sides are equal means anyhow these two triangles are symmetrical. Then only you will able to prove it that these two are equal. So let's prove it. Now see, angle AOP angle APO equal to angle VPO. Why? It is 90 degree. That is given. And OP side is common. OP side is common. So now, and what about OA and OB? These two are radius. Any point from the drawn from the center of the circle to the circumference of the circle is a radius. So these two are radius. So of course AO equal to BO. So now from here it implies that triangle AOP and triangle BOP are symmetrical. Okay, if it is symmetrical, then from here, therefore, side AP is equal to side BP. Now, you got it is given right angle, attaching at right angle. So now you got these two are equal. So this OP dividing the chords AB in two equal parts. If it touches the AB at right angle, this is opposite to the theorem 1. So this is all about this. Why it is AP and AP equal to BP? Because these two triangles, triangle APO and triangle BPO are symmetrical. We have proved it. Why? On what basis? Side angle side angle side. On this basis. So these two triangles are symmetrical. So this is now it is proved. So this is nothing but You have to just recall it. Okay, you have to recall. If any chord, any line done from the center of the circle to any chord, bisect the chord in the two theorem. I am telling you about the two theorem. It's just opposite to each other. Bisect the chord equally, then that line is at right angle to the chord. In other words, if a line drawn from the center of the circle to a chord AB is at right angle, then it bisects the chord in equal two parts. That is the opposite of theorem 1. So, we have learned some properties of chords in the circle. Now we are going to learn some more properties or more theorem of the circles here there in your syllabus. Suppose there are, I'm giving you one hint actually, I recall. Suppose we have learned that two chords when a perpendicular passing drawn from the center to the chord bisect the chord into two equal parts. Yes or no? Yes. Suppose chord AB. Suppose you are drawing another line parallel to AB, that is CD left. This parallel line will join the center, will also be at perpendicular and will both be equal. Got it? Similarly, suppose in a circle, suppose in a circle there is one chord at one side of here, like these two parallel lines, and another chord in the same side also. Then also line joining the center to the midpoint are perpendicular and intersect both the chords equally. So this also you can analyze from the last theorem. This you have to recall. Now we are coming to the next theorem. We have done two theorems done. So let it theorem 3. Which state that equal chords of a circle are equidistant from the center. Equal chords of a circle are at equidistance from the center. Suppose a circle equal chords of a circle are at equidistance from the center. Let two chords A, B and C, D and let the center is O. So let AB equal to chord AB equal to chord CD. Got it? So chord AB equal to chord CD. Now this is equal chord of a circle are at equidistance from the center. That means the distance from this line to this center and this line to this center should be equal, minimum distance. So how to know the minimum distance? What is the minimum distance from a point to a line? The perpendicular, the minimum distance. So draw a perpendicular line from point O to center O and perpendicular line from O to line CD, O to line AB and O to line CD. Let this point be P and let this point be Q. So now we got the minimum distance. So what we have to prove it? Equal chords of a circle are at equidistance from the center. We have to prove OP equal to OQ to prove. And what is given? Given is a chord AB equal to chord CD. Chord AB equal to chord CD. And you know that O touches the line AB at right angle. O touches the line AB at right angle. And CD touches the line OQ at right angle. So now join this. O, B and O, D. Join O, B and O, D. These two triangles. So now we are getting two triangles OPB and OQD. OBP and ODQ. These two triangles, what is common? Now You have to prove what you have to do. OP equal to OQ. OP equal to OQ. So if we can prove these two triangles are similar or congruent, then it will be easy for us to prove that OP equal to OQ. So now let's prove. So AB equal to CD. From the previous theorem, since it is perpendicular, you know that the line from center to a chord, if it is perpendicular, it bisects the chord in two equal parts. Isn't it? Isn't it? So now, so AP equal to BP and DQ equal to CQ. So OP equal to BP and DQ equal to CQ. Now you are getting these two. So these two are equal. Given is AB plus CD. What is AB? AB equal to AP plus BPB or BP. So AB equal to AP plus BP, and so AP and BP both are equal. So you can write it 2 into BP. Similarly in these triangles also, here also CD equal to CQ plus DQ. Now CD equal to CQ. Why? And it is here CQ equal to DQ. Also, since it's bisect, so since CQ equal to DQ, so therefore CD equal to 2 DQ. Got it? It's easy. Both are equal. So adding. So now it's 2 DQ. So AB equal to CD. AB equal to CD. You will put 2 BP equal to 2 DQ. How? CD, you are putting the CD value. AB, you are putting the AB value. So this implies BP equal to DQ. BP equal to DQ. So now we got one point. BP equal to DQ, and in the triangle OPQ, OPB and ODQ, OP equal to OQ. Why? Since it is radius. Sorry. Not OP. OB equal to O. OB equal to OD, since it is radius. So OP equal to OD, BP equal to since this radius so and angle OPB equal to angle DOQD in these two triangles. So we are getting two side BP D equal to DQ, OB equal to OD, and since it is right angle, so both are right angle means both are equal to 90 degree. As it is 90 degrees, so both are equal. Now the triangle BOP is similar with triangle DOQ, that is both are similar or congruent. Now both the triangles are congruent. We have proved that OPB and OQD are congruent. So since it is similar, both the triangles are similar, therefore OP is equal to OQ. Now you got OP equal to OQ. So now it is proved that 2 equal chords of a circle are at equidistance from the center of circle. Okay, now it is proved. So you got. So try to understand this. This is the main thing. How I am proving that you have to analyze. In that way, if you will analyze, then you can also yourself make some theorem.